All right, welcome to Activity 6.3. And the learning target for today is we're going to investigate the relationship between temperature, kinetic energy, thermal energy, and the molecules in liquids and gases. So by the end of this activity, I would expect you to be able to explain the differences between how molecules move in a solid, which we looked at in 6.2, a liquid, and a gas. Now we're going to explore a lot of the liquid today, but we're also going to look at a computer simulation of how gas molecules move. Now, if you were in class, what I'd have you do is fill up a 150 milliliter beaker of cold water. What I'd have you do then is, for number one, use a thermometer and record the temperature. Then what I had you do, or what have you done if you were in class, is I'd actually have you take some food coloring, a drop or two, and put it into cold water and simply observe what happens. And you're probably going to want to observe it for a few minutes. Now, I'd also have you do this with another 150 milliliter beaker, but then this would be hot water. And so the same thing, I'd have you boil some water with a Bunsen burner, I'd have you record a temperature, and then tell me what you observe happening with the food coloring. And the whole idea is I want you to be able to see what the difference is between the cold water and the hot water. So, now, we can't do that if you're not here. So what I did is I found for you a video. So I'm going to start the video right away. It takes about a minute. You can see that right down here. So you see the hot water and you see the cold water. So they're putting food coloring in both. So just take a minute, observe what happens, and write this down in number 2 for the cold water and number 4 for the hot water. And if you need to pause the video so you can write your observations down. And I suppose that's one of the advantages of watching the video versus actually doing the lab. Although if you do the lab, you actually get to use the Bunsen burners. So go ahead, pause the video right here. If you need to, record what you see happening, or you can just watch the video play out. So you got about 20 seconds left. Again, you're recording your observations. You can definitely see there's a difference between the two. All right, so we're going to pause the video right there, and let's go back to the SMART presentation. So you finished 1, 2, 3, and 4. Now if you look at number 5, 5 says watch a computer simulation that demonstrates the molecular motion of a liquid at high and low temperatures. Do the molecules of the liquid move faster at the high or the low temperature? So let me pull up the demonstration. So I've just got to bring it up here, pull it down. So here it is. So here's the computer simulation. So take a look at what the molecules are doing. Now notice there's a difference between these molecules in a liquid than the molecules that you saw in a solid in 6.2. So now let me heat it up so you can see that I'm sliding the cursor over there. So what do you see happening? So go ahead and rewind the video if you need to, or just let it play here. So again, you're answering number 5. Watch a computer simulation that demonstrates the molecular motion of a liquid at high and low temperatures. Do the molecules of the liquid move faster at the high or the lower temperatures? So go ahead, pause the video if you need to finish that question. All right, so now that was 5. And if I move forward, 6 wants you to watch, you basically answer the same question, except instead of a liquid or a solid that you saw in 6.2, we're going to take a look at a gas. So again, let me slide that up here, and I just need to find, all right, well, is this it? Nope. Let me slide this forward a little bit. So here they are heating. Now, sorry about this. Heating molecules of a gas. All right, so here's the computer simulation. So here's your gas. This is at a cooler temperature. Now, first of all, you should notice the difference between these molecules and the molecules you just saw in a liquid, and definitely different than the molecules that you saw in a solid not too long ago in 6.2. Okay, so let me heat it up. And now it's going faster and faster. So again, go ahead, answer the question. Do the molecules of a gas move faster at the high or the low temperatures? Pause the video if you need to answer the question. Now going back to our notebook file. So what I need you to do is I need you to finish up the conclusion questions. So if you look on page 69, there's 5 questions, 1, 2, 3, 4, and 5. So go ahead with your partner, answer those questions. Go ahead, pause the video until those questions have been answered. So now that you've had a chance to answer the question, here are the key points. Now, temperature is a measure of how vigorous the motion is of an object's molecules. The higher the temperature, the faster the molecules are moving. On the other hand, the Ke of the molecules tells us how much thermal energy the object has. So keep this in mind. If you increase the temperature, the motion of the molecules also increase. And if that increases, that means the Ke increases, which means also the thermal energy increases, because we've talked about how Te is dependent on the motion of the molecules, which is dependent, which basically if you have the motion of the molecules, you have more Ke. So as always, if you have any questions about this lab, feel free to ask your teachers. And again, if you are absent, show your teacher that you're finished with this activity. That way they'll know that you did it, and then be sure to ask questions about it in case some of these questions appear in a test. You don't want to be thinking, okay, I don't know how to answer this, and all of a sudden it appears in the test. So as always, thanks, and have a good night or day, or whenever you're watching this. Just thanks for watching it, and thanks for having complete full sentences.